Example 4. Alarm overrides via measured value. Welcome to the fourth example of applications for sun protection actuators. This time the topic is overriding by direct evaluation of the underlying analog signals. In this training unit, you will learn which analog signals can be processed, in which cases this makes sense, and how to set the parameters using the sun protection actuator N543 as an example. Instead of the binary alarms, which are already preset via a threshold value decision in the sensor, for example in a weather central, it is sometimes more sensible or even necessary to set these thresholds directly in the actuator. It can happen that plant equipment requires more limit values for alarm override than weather sensors can provide, which generate wind, rain, or frost alarms. A fine adjustment per channel can also be carried out with direct evaluation at the actuator. Also, several set levels connected in series can take up intermediate positions that cannot be changed by the user because they have priority as override. Let's now look at the sun protection actuator N543 again. The wind alarm from the last example should now be set directly to the wind speed value measured by the weather central. For this purpose, the parameter control value input is enabled on the page Override 1 Wind Alarm. Our equipment is again an awning. We want to define 6 meters a second with a downward hysteresis of 2 meters a second in this setting. If we open the list of possible data point types for this, it becomes clear that they are all analog values, from 8-bit to 4-byte. On the other hand, unfortunately we do not have the data unit of meters per second. However, this is not a problem, because the data point types represented here are only placeholders of a class of equivalent types. Instead of meters per second, temperature 2-byte floating point can be used. We enter the value 6 to trigger and the value 4 to reset the alarm. Fractional values are also possible, by entering a decimal point if required. The further procedure, for example, determination of the monitoring time, is completely identical to the previous example using binary override. Please also note the following. The parameters threshold value for on or off are not the control, but the activation or deactivation of the alarm. If the measured value requires an inverted activation, which is the case for example with a frost alarm, this must be set in the invert override input parameter. Applied to a frost alarm with the settings alarm below 4 degrees Celsius and no alarm above 6 degrees Celsius, this means that the values can remain exactly the same, but have the opposite effect due to the inversion. What should happen to the channel in each case can be set below as already shown. Finally, it should be noted that the monitoring function should also be active here. In this case, it must correspond to the cyclic transmission of the value measured by the weather station. In our case, the cyclic transmission of the weather station AP257 is set to 2 minutes. The monitoring time of the override can thus be set to 4.5 minutes. We are again at the end of this training module. You now know which value options the control value input offers and how to parameterize it correctly for the most important applications. The next application example deals with the sensible setting for distinguishing between manual and automatic operation. Stay tuned.